Hello F-sharp, and welcome to Performance Patterns. Today what we're going to discuss is one of the patterns that I use all the time when writing high-performance code. And it's a technique I use to map my domain types to raw integers. Because inside of a CPU, the fastest thing to work with is a raw integer. CPUs love integers. And so anytime we can map our operations down to them, we are going to get significant performance improvements. But one of the difficulties is knowing how to perform that mapping and how to go back and forth. And so what I want to show you is one of the simple techniques that I use to do this type of mapping. Now, to motivate this example, I'm going to talk about a simulation that would use, chickens on a farm. It sounds really silly, but it's innocuous. It's not going to offend anybody, and I think chickens are cute. So there you go. So the idea with this simulation is then we have a set of chickens, and we're going to want to model their location on the farm as the simulation progresses. So at each time step, there's this probability that a chicken is going to move from one location to another. And we want to keep track of that. Okay, that's the motivating example. Let's talk about what our types are right now. So right now we have this idea of a chicken, which it has a name, it has a size, and it has an age. And that is a string, a float, and an integer. And we are then going to generate a set of random chickens that I can go ahead and do that. So when I run that code, I'm going to get 100 random chickens. Now, the naive thing that we could do is saying, okay, we are going to just do some basic domain modeling. We know we need to be able to kind of mutate this data structure, and we need to be able to change location over time. And so we're going to model location as a single case discriminated union. And then we're going to keep track of the chicken's location in a dictionary where the key is the chicken and the location is this single case discriminated union. You could do this. The performance of it would be absolutely terrible. I want to give you a little context as to why. So instead of just giving you the answer, I want you to understand the impetus behind the thinking so you could develop your own engineering sense of how to reason about this code and what it will be doing. So hopefully very quickly, and I actually started doing this, and this is not my first take on this, but the idea is like, okay, well, if we're working with chickens and we're needing to be able to look them up, we have our stack over here, which is just this chunk of memory. And really the stack and the heap are all the same memory space, but we just like to visualize it this way for simplicity. And we have our heap over here. And right now, our chicken is actually a reference to somewhere out in the heap. That's going to be this blob of memory somewhere. And that inside of it is going to have a name field. And that field is a string, which is also going to be another reference to somewhere out on the heap, this chunk of memory. So when we want to do a dictionary lookup, we need to compute a hash code of our chicken, which involves going all over memory to get these values. That is not good. Now, we could start using things like, struct attribute to try to make this data more contiguous. But you also have this fundamental problem of you're still looking something up in a dictionary. Why am I saying that's a problem? Like, well, again, you probably have your dictionary as a reference somewhere here out in the stack, but that reference is pointing to where your dictionary actually appears in the heap. And the dictionary is going to have some metadata associated with it, but that dictionary also has a reference to an array somewhere where the values inside the array actually are. So to go look something up in the dictionary, to get the location for a given chicken, we first need to go get the chicken, which is going to be, we're going to have to dereference this. So this is potentially a cache hit. We are then also going to compute the hash code of our chicken, which involves having to look up this string somewhere, which is, again, we're following another reference, which is, again, potentially another cache hit, computing this hash code, coming back to our dictionary, looking up the dictionary, seeing where it is, and then we then have to compute the hash code, compute the index, and then we have to go look somewhere in an array. So to do this lookup, it is very expensive. What we would much rather do is be able to just index into an array. And what I mean by that is like, okay, let's say instead of using a dictionary for associating a chicken with a location, we're able to just say, no, this is the index of the chicken. The chicken is associated with this slot. So again, we still have our stack over here. And now what happens is we have some integer. We have some integer which is associated with a chicken. How we get this integer, we'll get there. But we have some integer that maps to a chicken, and then we have this locations. Locations is an array that exists somewhere out in the heap and into some chunk of memory. And so if we want to get the location for a chicken, we're going to say, okay, instead of using the raw chicken, we are using an integer in lieu of the chicken. Somehow we have mapped chickens to just raw integers. We have this chicken index, and then we can go and look up a value in this location array. That is a single lookup. That is a single, just like, boom, the array is here, and then we are able to index into it. So no computing hash codes, no having to go get the data to even compute the hash code, no mapping like this. If we're able to do this, it is outrageously faster to look things up. But here's the problem. How do we create this mapping here where we say like, okay, well, this integer is associated with this chicken. How do we do that mapping? That's what I want to show you. So if we come back here, we don't want to do this. What we really want is something that's like this, like, well, chicken location is actually just going to be some kind of location array. And why are you complaining? Oh, because it's, yeah, haha, okay. So I'm going to say like, this is going to be an array of some kind, and I'm going to say, I'm just going to fill this in. So we want this to be a location array of some kind. I know it's complaining, don't worry about it, but like, this is our goal. So that chicken location is just an array, and we have some integer which is associated with the chicken, so we can just, boom, index into it. That's what we want to be able to do. It is outrageously faster. How do we do this though? That's a great question. Let's talk through it. So this is the basic technique that I use, and I'm calling this performance pattern kind of index mapping. I'm sure there's a real name for it somewhere out there, but this mapping code I use all the time, this pattern, where again, I have the same domain, I still have my chickens, and then I have, I'm not actually going to use this dictionary here. Well, I am. And what I'm going to do is I have this dictionary, and this dictionary is going to hold my chicken name to index mapping. So the dictionary is going to say, hey, I'm going to associate this chicken name, and I'm going to make it even easier. I'm just going to make it easier. Just chicken to index. Yeah, let's just do a rename here. And I'm going to make this even simpler. I hate using fsharp records as keys and dictionaries, but for the sake of this demonstration, I'm going to just do it for simplicity, but you really shouldn't do it. So this dictionary is going to hold my mappings, where the key of this dictionary is going to be the chicken, and the value in the dictionary is going to be the integer I want associated with that chicken. And so what I do is I'm going to loop through all my chickens, and I'm going to say like, hey, does this chicken already exist in my dictionary? If the chicken does not exist in my dictionary already, what I'm going to do is I'm going to add a new entry into the dictionary. So for this key of chicken, I'm going to associate this integer. What is this integer? It is the count of elements that are in the dictionary. So when this starts out at the very beginning, there are no chickens in the dictionary. First chicken comes in. Does this chicken exist in my chicken to index mapping dictionary? No. Okay, add the entry. So for this key, this chicken key, the index I'm going to use, the integer value I'm going to use is the current count in the dictionary. Initially, that count is 0. Great. I go to the next chicken, and let's say it's a new chicken. Does it exist in the dictionary? No, it does not. Okay, add it. This key, this new chicken, is associated with the count. What is the count now? It's 1. And so this is automatically going to create a series of integer values starting with 0, and we can associate with every new value of chicken that we find. Fantastic. So then what we can do, now that we've computed this, I'm going to go ahead and run this so we can see what the result is. We have this, and this is the values in our dictionary, where we have this chicken. This is Clucky 34. And it is associated with the integer value of 33 in this dictionary. Great. Now I have this mapping code, so I can map from my domain, my chicken domain, down to the integer that is now associated with that chicken. And so what I can do now is, let's say, so now when I want to model things in my domain, I can use a raw array, and this integer value is the index I'm going to use into the array. Say like, okay, if I ever want to look up something about Clucky 34, I use the chicken index value of 33 to index into the array that has all the information about the chickens. So that is how I create this association. Now, what happens when we need to go the other way? So let's say you run your simulation, you're just working with these raw integers that are the indexes for your chicken. What happens when I need to invert that? And I say like, okay, I need to go from these raw integers back to the chicken that was associated with them. Well, then we have this little piece of code, and this looks a little intimidating. I'm not going to lie, but we will walk through it. What we're going to do is we're going to take that same chicken to index dictionary where the key is the chicken and the value is the integer associated with the chicken. We are going to use an active pattern. In this case, it's the key value active pattern. And what it does is it takes a key value pair, which is what is coming out of the dictionary, and it breaks it into a tuple where the left element is the key and the right element is the value. I then flip the order of them. So now the left value is the integer key and the right value is the chicken. I then tell it, okay, sort by the integer key. So now we know that these values started at 0 and we know they are incrementing. They're going up. So sort by those, then just give me the key associated with it, which in this case is our chickens. So the second element is chicken, and then turn that into an array. And what this array is going to be, oh, no, I want to run this code. Run this code. What this array is, and I'm just going to show just a chunk of it. I'm just going to show the first few elements of it. Index to chicken name. And I'm going to say, hey, just show me the first few elements. So it's easier to see. I'm going to go even fewer. Okay. So if I look at the first 3 elements in this array, we can see like, okay, these are chickens. And in the 0th place is Clucky 1. In the first place is Clucky 2. In the third place is Clucky 3. In the fourth place is Clucky 4. Okay. So that 0th index corresponds to Clucky 1. Well, let's go look up. Let's go look up what index is associated with Clucky 1. And to get that, I'm going to have to get the first element. So this is Clucky 1. Let Clucky 1 equal chickens. And again, I'm getting the first element. So I got like, okay, I got clucky one. See, we have here, we looked up that 0th element in chickens. And I say, okay, what is the index associated with clucky 1? It's 0. Okay, so I'm wanting to show you these pieces all together. And I'm just gonna move this down here. So, come on. So when I want to look up which index is associated with the chicken, I can use the chicken to index dictionary. And that's going to say, hey, for clucky 1 maps to the 0th index. And then if I want to go from the 0th index back to what chicken is associated with that, I would use index to chicken name. So in this case, I would use 0, and I should get clucky 1. So this is how I'm able to go back and forth between a chicken to the integer that represents the chicken, and from the integer that represents the chicken back to the chicken. Because when I want to work in engine code, I want to work with the integers. I don't want to work with the fsharp record because working with that larger chunk of data is slower. That's just what's going on. Okay. Now that we're showing how we can create a mapping from an fsharp record chicken to an integer index and then take that integer index and go back to the fsharp record, this is really easy to lose track of things. I'm not going to lie. I have dyslexia, and keeping track of like what integers are meant to represent and they're flying around everywhere, just working with raw integer indexing, that would be very intimidating. It'd be very difficult. I'm not going to lie. Now, fortunately, fsharp has an additional feature that I rely on heavily, and that is units of measure. And I actually have a video where I introduce the idea of units of measure and how I use them, and I'm going to use some of those techniques right now. I would love for these index values to not just be raw integers. I would much rather that we associate that integer with what it is meant to represent. And so to do that, I'm going to use units of measure. And I'm going to show that right here. So again, I have my type chicken, I have generated my random chickens, I have my chicken to name index, which is again that dictionary. And I'm going to go ahead and move this code back up here. Oh no, it has to be down here because of what I'm doing. But I need to change this slightly to match what I was doing on the previous one. Doing it live. So I can move this down here though. That's better. So, and this doesn't need to be up here. Some live editing, folks. So now I'm going to start taking advantage of some units of measure stuff. So I've got my random chickens. This is again a pattern that I use all the time, is I will often have a module which contains all the units of measure I'm going to be using in my engine code or my domain. And I throw everything in there and I say, okay, I have this unit of measure, which is my chicken index. I then define what a chicken index is outside of it, saying, hey, a chicken index is an integer with the units of chicken index. And I then have a module for creating instances of chicken index, just to make it easy on myself. And I have some light domain validation here, where it's saying, hey, I'm not expecting to ever create a chicken index with a value less than 0. Because the idea is that it's meant for indexing into an array. And so the values should be from 0 ascending. And so I give myself this convenience function to make sure that I'm making sensible chicken indexes from raw integers. I have the same code where I want a dictionary where I'm going to map, and again, I'm going to change this name to chicken to index, where I'm going to map a chicken to an integer index associated with that chicken. But instead of just storing the raw count number like I did before, I'm going to use this chicken index.create function, and I'm going to add domain context to the integer and saying, like, hey, this is the unit of measure associated with this integer. This is not just a raw integer. It is meant to represent something very specific, and that is the chicken index. Okay, so I have this dictionary. The key is chicken. The value associated with it is the chicken index. Now, I introduce the idea of a bar. And again, I have another video where I talk about the idea of a bar. But what a bar is it's just an extremely light wrapper around an array. And it gives you a nice syntax for saying, hey, I want to go get an element in this array, but that indexing element has a unit of measure associated with that. And the bar is making sure that the units of measure match, so that when you go to try to look up a value in this array, you're not using some arbitrary index, like you're using an index with the correct unit of measure. And then it returns the value to you. So now what I'm doing is I'm saying, okay, index to chicken name is I take the chicken index, I do that same set of transforms, but then I have a bar of sequence. And so what this does is it creates that array wrapper that is going to enforce correct units of measure on the indexing variable. And I'm going to go ahead and run all this. And now I should have this. So index to chicken name is now a bar, which is going to force you to use your indexing integer to have the units of chicken index, and it's going to give you your chicken back. So now I have the ability to say, like, hey, give me a chicken index of 0. So now this is no longer just this raw integer. It is an integer with a unit of measure that is meant to signify what it is meant to represent. And I can then look up, hey, given an index, what is the chicken associated with that index? And so this is how I actually do the mapping back and forth. I'm not just mapping fsharp records to raw integers. I'm mapping them to an integer with a unit of measure that indicates what it is meant to represent or what it is meant to stand in lieu of. So this allows me to be working in the engine code with raw integers, but have domain correctness and be extremely performant. So again, this is like one of those patterns that I use all the time, is that, hey, a modeler might want to work with the plain, not sure that's quite the right word, but the modeler wants to work with the beautiful, simple domain representation that fsharp allows you to create. But then once I want to do engine code, I don't want to be doing dictionary lookups on fsharp records or anything like that. I want to map all those things down to raw integers so that I can be working with those. And then I can map back from those raw integer representations back to the types that the modeler was expected. And so this pattern I use all the time. And so when I start going to showing you some more simulation code, you should expect to be able to see this kind of mapping back and forth all the time. So I know that was quite a bit. Let me know if you need me to go dive into something more and to provide more clarification. There's going to be quite a few of these performance pattern series to kind of build up these patterns that we're going to be using to be writing high performance code. But this is probably one of the ones that I use absolutely the most. And so until next time, thank you very much for spending some time with me. I really appreciate it. You have a great day. Bye-bye.